Hi, everyone. My name is Madhura Bhave, and I'm a developer on the Spring Boot team at Pivotal. I hope you're having a good conference so far. And in today's talk, we're going to be taking a closer look at what really happens when a Spring Boot application runs, what goes on behind the scenes. A lot of times we hear things like Spring Boot is too much magic. We know it does a lot out of the box, but we don't really know what's going on. We see developers just, if things don't work, they stick on some annotations and leave them there. If things work, and then new developers come onto the team, they don't dare to touch the annotations because they're too scared to break things. So I just want to show you that there is no such thing as magic. It's all code, and you can all look at it, debug it, and make sense out of it. So before we get started with the demo, I want to show you what this getting started experience is that I'm talking about. Most of you are actually familiar with starterspring.io, so I'm just going to use that to create a new application. I'm using IntelliJ, but you can use any other IDE or even go to start.spring.io to generate a new project. And I'm going to call it Demo 21 because I have 20 other demos. I'm just going to select the web starter for this simple demo and finish. So as a lot of you are familiar with this structure of a Spring Boot application, we have the Spring Boot starter web, and there's a demo application class that gets created for you when you generate your project from start.spring.io. So the Spring Boot application annotation is basically what gives you a lot of the goodness that you get out of the box with when you run a Spring Boot application. And I'm just going to run this. So as expected, it starts up on Tomcat by default on port 8080, which means that your application is up and running and ready to serve web requests. It's kind of interesting because we literally didn't have to do much, and we have a running application on Tomcat. Obviously, it's not going to really serve anything useful at the moment because we don't have any controllers or anything. But it is a running application without having to do too much. This can seem a bit magical, I suppose, if you don't really understand what's going on behind the scenes. So the idea is to rebuild this application that we just saw running, and we have all the technology. We're going to start building the application from scratch, and as we rebuild it, you'll sort of see what Spring Boot was actually doing for you behind the scenes and what you don't need to do when you use Spring Boot to get the application running. So let's start from scratch. When I say scratch, I'm still going to use some components of Spring Boot because I only have 50 minutes, so I'm still going to use the Spring application.run method. But I'm not going to use any of the Spring Boot application annotation or any of the auto-configuration stuff that you get with Spring Boot to begin with. And then we'll start building the app. As we start building the application, you'll see what needs to be added. And you'll sort of see what the thought process was behind some of the Spring Boot annotations and features. Is the font OK? I guess I can't really see you, so I'll assume it's OK. So it's not really live coding. I have a bunch of commits lined up, so we'll go checking out each commit and adding things as we need to add them. So just a quick look at the pom.xml. It's similar to the application that was generated from starterspring.io. It has the Spring Boot starter web. And the application class is a bit different. It still uses Spring application and the main method, but it's not using at Spring Boot application. So now if we run this application, it fails. And the failure is that it's unable to start a Servlet web server application context due to missing Servlet web server factory bean. So before we actually go ahead and fix this failure, I wanted to give you a little bit of perspective about what this means. And for that, let's take a quick look at how things were before there was an embedded servlet container that you typically get with a Spring Boot application, and what it means to now have an embedded servlet container. So previously, you used to have this web container, such as Tomcat, to which you would deploy a WAR file. And the servlet container would then look for a servlet container initializer within that WAR. And Spring has its own servlet container initializer implementation, which then looks for a web application initializer. And one of the web application initializers is one that registers a dispatcher servlet with the servlet container. So that thing used to register the dispatcher servlet, which then has access to the web application context and all the beans. So this used to be the case when, or still is the case if you deploy a WAR file to a non-embedded servlet container. Now, in today's world, with Spring Boot applications, you have the embedded servlet container. I think up until Spring Boot 1.5, this used to actually be called the embedded web application context, but we changed it with Spring Boot 2 to be Servlet Web Server Application Context because there was a reactive counterpart that was added in Spring Boot 2. So this Servlet Web Server Application Context is actually an application context that knows how to bootstrap itself by looking for a Servlet Web Server Factory bean within the application context itself. And the Servlet Web Server Factory bean will then give you a web server using some of the servlet context initializers that are available within the application context itself. So the web server is something such as Tomcat, Undertow, Jetty, which can be started and stopped. And like I mentioned before, the web server, when it is created, it gets the servlet context initializers that are present in the application context then get applied to the web server as it starts up. So again, those are registered as beans. OK, so now that we have some perspective about the fact that because this is a web application, this Servlet Web Server Application context is looking for this Servlet Web Server Factory bean to bootstrap itself and start up the embedded servlet container. So let's go ahead and add that bean. So I'm just adding a bean for the Tomcat Servlet Web Server Factory so that it matches the default of what we got with the application that we saw from start.spring.io. And rerunning the application. So it did start up on Tomcat port 8080 now, which is what we would expect because the application context was able to find this bean, create the web server, and start it up. So even though we have a running server, just like I mentioned before, it's not going to do anything really useful. It's just going to give us a 404 because we don't have any controller mappings to handle these requests. So we'll start building this one by one. I'm just going to check out the commit, which adds a REST controller. And it's a very simple REST controller, which probably most of you are familiar with. It has just one request mapping to slash, and it returns hello world. So if I run this, how many of you think this will actually work and serve hello world? One person thinks it'll work. OK. So it didn't work, sorry. And it didn't work because we still don't have a lot of the plumbing that you need to get the Spring MVC stuff working. Just adding a REST controller, it works in a Spring Boot application because Spring Boot is actually doing a lot of the plumbing for you. But now, because we're building from scratch, we have to do it ourselves. So the first thing that I'm going to do is add this enable web MVC annotation, and that will basically import all the web MVC configuration that you need for handling this request. So let's run it again. So it still doesn't work. And the last thing, actually, that you need to do is add a dispatcher servlet. So the dispatcher servlet, we'll look into it a little bit later in the slides, is the central dispatcher for HTTP requests, which knows how to handle your requests and then route them to the right controller. So once we add the dispatcher servlet bean, it does work, and it gives you hello world. So that was actually quite a bit of groundwork that we had to do to get just a simple REST controller working, which you don't really have to think about. If you were using the @Spring Boot application annotation, this would have automatically been done for you. But this is actually some of what is going on behind the scenes when the application starts up as a web app. So we looked a little bit at how when the Servlet web server application context starts up, it applies the Servlet context initializer beans to the web server, and it also registers existing Servlet and filter beans that it finds in the application context with the web server. So the dispatcher servlet is basically a servlet implementation. And like I mentioned, it is the central dispatcher for all HTTP requests, and it knows how to handle your HTTP request and route it to the right handler based on the handler mappings. So when you have something like a request mapping of foo or a request mapping of bar on your controller or on one of your controller methods, and you get a request, you make a request via your browser or any other client, it goes through the dispatcher servlet, and the dispatcher servlet, because it's aware of all the mappings, it knows the right controller to route that to. Right. So we have a running web application, which is great. And the next thing that we should do is we have everything in this one application class here. So instead of having this REST controller within the application class itself, we should try and move it out of the application class, because when you want to add more request mappings and more functionality to the controller, you don't want it to be all within the application class. So I'm going to extract the controller out into its own class here. It's basically the same code, just sitting in a separate class. But if I run this application again, you'd think it would work. But I'm back to my 404. And that's because I've moved it out, Spring doesn't really know that it needs to register this controller as a bean, because I don't have the component scanning annotation. So let's go ahead and add component scanning. And what the add component scan will do is, by default, it will scan all the packages from the package of the class that the annotation is declared on. So now, because application is within the example package and hello controller is in that same package, it should be able to find this controller using component scanning, and we should be back to our working web application. So yeah, we're back to hello world. Again, this is something like when you add component scanning, when you have the add Spring Boot application annotation, you don't necessarily need to think about it, because again, it's part of that annotation. So you might not necessarily have added it yourself on your application. But this is one of the things that is going on behind the scenes by default. OK. the next thing we should do is we've also declared these beans within the application class. So let's try and extract them into their own configuration classes so that it's more structured in a way. So instead of having all those configuration beans in the application class, I've moved them into this config package. Maybe this config package can later be shared because this does seem like quite a common configuration for most web applications, declaring a dispatcher servlet bean, enabling web MVC, and having a servlet web server factory bean. So like I mentioned before, component scanning will only work from the base package of the class that the annotation is declared in. And now, because we've moved our configuration classes to a different package, I expect that our application will be back to an error because it can't find the servlet web server factory bean again. So the servlet web server factory bean is declared in this configuration, which is in a different package from the one that's being scanned. So we need to explicitly tell Spring that we want to import these configuration classes because they're not being scanned by default at the moment. So let me just do that real quick. So because we've moved them to a different package, I've just added an explicit import statement on the application class telling it to register the beans that are in this configuration class, in these configuration classes. And that should take us back to our running application. So if I run it, it didn't fail with the error of the missing web servlet factory bean. And it's also giving us hello world, which is what we expect. So a little bit about component scan. The component scan annotation is basically a way of telling Spring where to look for your components, so anything like your controllers or your configuration classes. Those will be automatically scanned. The default is the package of the class that the annotation is declared on. You can obviously change the default using the base packages or base package classes attributes. But if you have something that looks like this, so your application is structured in this way, where you have the demo package and then core, domain, and config, let's say, under demo. And then let's say your application class is in the demo package, and application has the @component scan annotation. So everything under that demo package will be scanned by default. But let's say you were to move your config package outside of demo, which is what we had in our application, that anything under that config package will not be scanned anymore, which is what we saw and which is why we had to do the manual import. Okay, so we have a pretty much running application now, and one of the things that you notice here is this application class now has a lot of annotations, which doesn't give it a very clean look. Also, all these annotations look like they could be shared by other applications, other web applications, because it seems to be a pretty common pattern for web applications to do everything that we just did. So what we'll do is we'll go ahead and create a meta annotation. And the meta annotation is nothing but an annotation which is going to be composed of these 3 annotations. So I've called it magic application, and as you can tell, it's pretty similar to the @Spring Boot application. It's annotated with the 3 annotations that we had previously, all stuck on the application class. So I've just moved them behind to this magic application annotation. And things should just work as they are, but I'll run it anyway. So the app is up, and we still see the hello world. So the next thing that I wanted to talk about a little bit is meta annotations. It's not really a Spring Boot thing, but we use it quite heavily within Spring Boot and within Spring Framework itself. So if you're debugging something that's going wrong in your application and you see that there's an annotation in your application, you might want to dig a bit further and look at what other annotations that annotation pulls in so you can see what's going on. So I think most Spring applications can be used as meta annotations. You can also use them in your own code if you want to compose annotations into one annotation. Spring Framework uses them quite heavily. So one of the examples is dress controller, which we just used. There's also get mapping, which you might be familiar with. So get mapping is actually meta annotated with at request mapping, but it has a method of get. So it's a convenient way to say, I want a request mapping with a get method. There's also some advanced configuration that you get with meta annotations. So if the composed annotation wants to expose some of the attributes from the underlying annotations, it can use this alias for annotation on the attribute, and then that will map to the attribute in the underlying annotation. So in this example, we have the Spring Boot application annotation, which is meta-annotated with, let's say, at enable auto configuration and at component scan. So the exclude attribute is an alias for enable auto configurations exclude. And scan base packages on Spring Boot application is an alias for component scans base packages. OK. So I think if you look at this config package now, it's starting to look a lot like what Spring Boot gives you. So you have your magic application annotation, which can map to the Spring Boot application annotation. And then you have these configuration classes, which maybe you can sort of map to the auto configuration classes that you get with Spring Boot. But one of the things that you see here is that this is still hard-coded here. So there's still Tomcat configuration, dispatcher servlet configuration, and MVC configuration hard-coded in the import annotation. So what I'm going to do before actually removing the hard coding, let me show you something related to auto configuration. So instead of this import annotation here, what I've done is on magic application, I've meta-annotated it with this new annotation, enable magic auto configuration. And that's basically has the import for Tomcat configuration and all the other configurations that we had. And the reason why I did this here is because if you want to use, let's say, component scanning, but not use, if you want to use the auto configuration bits, but not use component scanning, before the enable magic auto configuration annotation, the only way to do that was to have to know about everything that it gets imported via this import annotation, right? Otherwise, you were stuck to using the magic application annotation, which would bring in everything, including component scanning. So this gives you a nice way to separate component scanning from auto configuration, and which is why there's this separate annotation here. So like I mentioned before, it's still hard-coded here. There's no way to add any sort of logic in this import statement. So I can't do anything like if Tomcat is present on the class path, then import this Tomcat configuration and things like that. So the import annotation is actually pretty handy because it not only lets you import configuration classes, but it also gives you a way to import this thing called import selectors. So instead of having an import which takes all the configuration classes, we can have this import selector, which basically gives you an array of strings. And then here you can add any kind of logic or conditionals if you want to for selecting imports. The reason I'm showing you this is I want to show you how, what kind of the thought process was behind some of the Spring Boot auto-configuration features that are available. So this is just a road towards that. And even though you can add logic here in this import selector, there's no way for other people to contribute their own configuration classes to this annotation. So if you've ever written your own auto-configuration, you've probably used the spring.factories file in order to contribute your auto-configurations to the Spring Boot applications that use it. So let's take a look at how that works. So the import selector now, instead of returning that hard-coded list of configuration classes, it is using the Spring Factories loader to look for configuration classes that it needs to import. That's, again, very similar to how Spring Boot does is for all the auto-configuration classes, we list them under in spring.factories under a given key name, and that's how they get loaded. So if we look at spring.factories, which is in meta-inf, you can see that the three configuration classes that were being imported, that were being hard-coded, have now moved to this enable magic auto-configuration key, and the import selector then just looks for that, anything under that key. Okay, so we looked a little bit about looked a little bit at imports. You can import regular configuration classes directly if that's what you want to do. That's probably most of the use cases, maybe if you're writing applications. But for more advanced use cases, you might want to use an import selector. And for even more advanced use cases, if you want to deal directly with bean definitions, you can also import an import bean definition registrar and directly register bean definitions via that. And spring.factories is basically a very simple way to discover implementations. So it's kind of like Java's service loader. It's basically a very simple properties file that always lives under meta-inf spring.factories. So all the auto configurations will be present in spring.factories. And you can put it under the key of enable. I mean, for auto configuration, it'll be under enable auto configuration, and it'll be a list of everything that needs to be configured. Great. OK. So one of the very important things about Spring Boot's auto configuration is conditionals. And a lot of times we hear things like, how does Spring Boot know what to auto configure? Or how does Spring Boot know that it needs to start up Tomcat? And what if Tomcat is not on the class path? And things like that. So we'll take a look at an example of how this works here by adding this undertow configuration. So this configuration basically adds an undertow servlet web server factory bean. We still have our Tomcat servlet web server factory bean. So now we have two servlet web server factory beans. And if we run this application, it fails. And it fails not because it couldn't find a servlet web server factory bean, but it fails because it found multiple servlet web server factory beans. So we need to tell our application to only configure one of these based on some condition. And the way you can do that is by using the condition interface from Spring Framework. So we've added one condition for undertow, which basically says that if undertow is present on the class path, then add this configuration. So we've written this custom configuration which checks for the presence of undertow on the class path and annotated the undertow configuration with @conditional on that condition. Similarly, for Tomcat, we've added a condition that checks for the presence of Tomcat on the class path and added a conditional on the Tomcat configuration. So now if I run the application, it should work because only one of these will kick in, and that is Tomcat, because we have Tomcat on our class path. So this is how Spring Boot does a lot of the auto configuration by looking for conditional on class something. So let's say you have auto configuration for Spring Session. That will only kick in if Spring Session is on your class path. Otherwise, things would blow up like we just saw. So even though we have conditions here, what we should ideally do is move these conditions to a single condition because they are, it is duplicated code, so it's just checking for the presence of a class on the class path. And for that, let's add a custom conditional on a class annotation. So again, it's very similar to conditional on class in Spring Boot, showing you what conditional on class does behind the scenes. And conditional on a class takes this on a class condition, and it's basically doing what we were doing in our separate conditions for undertow and Tomcat, but it's getting the class name attribute from the annotation and then checking for the presence of that class on the class path. So if you look at Tomcat configuration, it doesn't have that custom condition here. It just uses the conditional on a class annotation. And it says that the class name is Tomcat. So if Tomcat is on the class path, use that. Otherwise, for undertow, it's the same thing. So the conditional annotation is, so the interface is in Spring Framework, and you can use the conditional annotation even within your code if you want to, but we use it pretty extensively in Spring Boot's auto configuration. There are things like conditional on class, conditional on bean. So let's say the auto configuration provides a bean. Spring Boot's auto configuration will back off if the user provides a bean. So if your application provides a bean, Spring Boot will be like, this thing is conditional on bean, so I'm not going to provide my auto configuration because the user has already provided theirs. Conditions also used in Spring Framework in places like @profile. So @profile is actually a condition underneath. And the conditions are, within Spring Boot at least, the conditions are ordered. So we try to order them so that the fastest ones run first. So I think the conditional on class one has the highest precedence, so that will run first. And if the class is not found at all, nothing under that auto configuration will need to be configured. And the last thing that the last piece that I wanted to show in a Spring Boot application is adding a property. So in Spring Boot, you have this thing called configuration properties, where you can specify a property in an external configuration, and that gets bound to your configuration properties class. So to build towards that, let's say we have this Tomcat configuration. So for starters, before adding any of the thing that the configuration properties does, what I've done is just use the value annotation from Spring Framework, and it'll look for a property called port. So if you want to configure your port to something other than 8080, you can use that. And that'll work. So if I run the application in, actually I haven't specified the application properties yet, so let me check out the next commit. But before that, if I run this application, it fails with a number format exception. And I think that's because I don't have the property sources placeholder configuration. So I have added this configuration for the property sources placeholder configurer. Again, this is something you don't need to typically do. This is all happening behind the scenes. But just to give you an idea of what's going on behind the scenes, this should now work. So the application is up, and it's still running on port 8080, which was the default, which is, again, the default that we've used in the value annotation if port is not found. So if we were to change that, so I've added this file called magic.properties and specified the port 9090. So if I run that, maybe some of you expect that it will run on 9090 now because I've added it as a property. But it's actually still starting up on port 8080. So there's more configuration. To process this properties file, we've added a file, but nothing is really processing it at the moment. In a Spring Boot application, if you add an application.properties file or an application.yaml file, that automatically gets processed for you behind the scenes. But here, we need to add that configuration ourselves. So there's this environment post-processor that is available with any Spring Boot application. And you can implement that to add things to the environment if you want to. In this case, we're just going to read the magic.properties file from the class path and get the properties from that file and store it as a property source in the environment. So now finally, after all this configuration, the server has started on port 9090, which is what we specified in our properties file. But again, the value annotation is not type safe, and configuration properties is a good alternative towards that, to the value annotation. So even though we do have our server up on port 9090 here, we should go ahead and add something that makes use of the type safety features. So instead of using the @value annotation, now we're using this class, server properties. So in server properties, we have a port which you can then set to whatever value you want. So in magic.properties, we still have port 9090, and we've used server properties in the Tomcat configuration class. But again, if I run this, it fails because it says that the Tomcat configuration needs a bean of type config.server properties, but it doesn't find that bean. And that's because nothing is really creating that bean for you in this application. So we need to do that ourselves. And the way I've done it here, which is kind of similar to the way Spring Boot does it, is using, sorry, I just need to look for the class. This enable magic properties registrar. So we looked a little bit at the import bean definition registrars that you can use in your import annotations. And this enable magic properties registrar is an import bean registrar. And what it does is it basically registers any bean that is annotated with, hold on, sorry. So in our enable magic properties annotation, we've specified that we want to enable the server properties class. So what that means is that the enable magic properties import bean definition registrar will register this bean, and it will also bind the properties from the properties file to this class. So it's basically got an import statement on and says that it's importing the enable magic properties registrar. And the registrar has all the logic for the binding that goes on when that bean is created. So I've used this binder from Spring Boot 2. And when you have configuration properties in your Spring Boot application, there is an enable configuration properties annotation, which you might have used to enable your own properties. And behind the scenes, this is what's happening. There is an import bean definition registrar, which will register the bean and bind the properties that it finds from application.properties to that bean. So if we run it now, we should have the server properties being created, and it should have been bound with port 9090, which is what is specified in the properties file. So just a quick look at this config package here. A lot of these things, like the conditional on a class, the enable magic auto configuration, enable magic properties, magic application, and things that we just added, they look very similar to the annotations that Spring Boot gives you. So we just basically created an application from scratch and added stuff one by one that you would have got out of the box with Spring Boot. But hopefully this gave you an idea of what needs to be configured behind the scenes so that you get this running application and a faster getting started experience. So again, just to recap, the conditionals, they map to conditional on class. The magic application was the meta annotation. So Spring Boot application is also a meta annotation. If you find that you're having issues with component scanning, you can always look at the, dig deeper into the component scanning aspect, or you can dig deeper into the enable auto configuration aspect of the Spring Boot application annotation. Enable magic auto configuration is the annotation that was importing our configuration classes in this application. In Spring Boot, it maps to enable auto configuration, which brings in all the auto configuration that are registered in Spring.Factories. And the star configuration classes like Tomcat configuration, undertow configuration that we added basically maps to the auto configurations, like the auto configuration for servlets, so servlet auto configuration, which will add the Tomcat beans and the undertow beans for you. So basically, the idea was to show you that there is no such thing as magic. We just built everything from scratch, and we were able to build everything with code. So there's no magic. It's that everything is in code. And for debugging Spring applications or Spring Boot applications, just follow the breadcrumbs. Look at what annotations are on the application. Look at what imports are being used or what import selectors are being used. And then you can put breakpoints in that and debug it if you need to. Spring.Factories is a way for you to contribute more auto configuration if you're writing that. And conditions is the way Spring Boot auto configuration knows when to back off, when to contribute certain beans, and things like that. Also, it's all open source, so use the source if you need to for debugging, and hopefully that'll help you develop better applications. Thank you.